Back to AK Apt Logics. In the previous class, we have discussed about the C numeric data types. Today in this class, we are going to discuss the continuation part to it. So I already discussed about the set precision in the previous class. Today in this class, we are going to discuss about that particular topic in detail. It means we are going to discuss only that topic in this video again. Okay. So let's move into the video. So we are going to discuss about the C decimal precision. Okay. This is applicable for the float and double numbers. Set decimal precision. Okay, you have probably already noticed that if you print a floating point number, the output will show many digits after the decimal point. Okay, like for float it is going to show us 6 to 7 digits. For double it is going to show you 15 digits, but in this compare it is going to show you only 6 digits for the double and float as well. For if you are going to use any other compiler, for float it is going to show you 6 to 7 decimal digits, and for double it is going to show you 15 digits. Okay, after the decimal point. Example, float, my float number is equal to 3.5. My float num is a variable which is of type float, and we have assigned the 3.5 which is a floating point number to it. Double, my double num is equal to 19.99. My double num is a variable which is of type double, and we have assigned 19.99 value to it. Okay, next, printf. We are going to print the my float number with the help of the printf, and we have used %f, which is the format specifier for the floating point number, and the output that we are going to expect is 3.5. After that we are going to get 5 zeros. Okay, why? Because the precision of floating point number is 6. Double, when you are going to print the double number, my double number, okay, with the help of the we are going to use the %lf. %lf is the %lf is the format specifier for the double variable. When you are wanting to print the double number or double variable, then you need to use the %lf. Next, let me execute this code for you and show you the output, whether we are going to get the output as we expected. Okay, I am going to add the standard input output header file. Why? Because we have used the printf function in our code, and I am going to give the int main function where our C programming starts to execute it. Okay, execution of C program is always started with the int main function. Okay, and I am going to include return 0. If you are going to include or not, no problem, but it is better to include. A good programmer always include the return 0. It is going to take a time. Okay, I have I run the GCC, so I'm going to run the executable file. Okay, and you can see the output that we have expected. We have got the same output as we expected. Okay, this is the output of our code. Now set precision means we are going to get the empty zeros right after decimal point. We need to eliminate them. Okay, we need to set the precision, how many number of digits after the decimal point we need. We have to set that. Okay, for that what we are going to do, let us see. Already this thing I have discussed in the previous class. If you have watched the previous class, then you no need to watch this particular video. Okay, if you want to remove the extra zeros, then we need to use the concept called set decimal precision. You can use dot followed by a number that specifies how many digits that should be shown after the decimal point. Okay, %f, right? In between percentile and f, you need to place a dot, and after dot you need to mention the number which indicates the how many number of digits that you need to get printed on your console after the decimal point. Okay, for example, float my num is equal to 3.5. we are going to use the %f to print the floating point number without any setting the precision. Okay, this is normally showing the value that is 3.5 after 5 zeros. Okay, and we are going to use another printf. Okay, and I have given the 0.1 in between percentile and f. Then what happens is, after decimal point it is going to print only one digit. Okay, after decimal point it is going to print only one digit. So percentile dot to f, after decimal point it is going to print two digits, it means 3.50. okay, like this it is going to happen. And percentile point 0.4 f means after decimal point it is going to print four digits, it means 530. Okay, so let me execute the code for you. To execute it, we need to have this standard input output library, and then int main. We need to put all these statements in the int main, and then return 0. Save the code and then run it. You can see the output, right? For first case, what we have got the complete number without setting the precision. We have given it, we have used the percentile f, right? So that we got 3.5 and then followed by 5 zeros. After that we have set the precision to 1, means after decimal point we need one digit needed to be printed. You can see 3.5, right? Only one digit is got printed. And after that what we have done is we have given 0.2. it means after decimal point we have got only two digits. After that we have given 0.4, we have got four digits of the decimal point. Okay, and for suppose if you are going to, if your number is like this, okay, already this thing I have discussed in the previous class, don't worry. If your number is like this, if you want let me remove all this. Okay, if you want you two digits needed to print it, okay, then what will happen is, see, you want two digits needed to get printed, then what will be the output? 3.56 or 3.57? It will be 3.56. okay, for example, if your number is like this, instead of 4 at the end, if you are going to have 5, then what happens? Let me know. Then what will happen? 3.57. Why 3.57? Why 3.56 in the previous case means, whenever there is a number from 0 to 4, then the number will be just ignored. Okay, the previous number won't be incremented by 1. Okay, whenever the number is from 5 to 9, then the number will be ignored, and also the previous number will be incremented by 1. It means we are going to round up. We are going to round up the number whenever the number is from 5 to 9. We are just ignoring the number whenever the number is from 0 to 4. This point you need to remember. Okay, this thing I have discussed in the previous class, don't worry. Okay, so if you have watched the previous full video, then you can ignore this video. Okay, I hope completed everything. Okay, let me summarize the video. Already I have summarized. So summary: use dot precision value, use percentile dot precision underscore format specifier. Okay, this point you need to remember, and a point, very small point, that which makes a more difference is, when number is from 0 to 4, then ignore the number, and when number is from 5 to 9, then ignore the number, and increment the previous number by 1. Okay, this point you need to remember. These are the summary points of this lecture. So I hope you guys understood this lecture. Okay, have a nice day. Thank you.